The first and foremost important thing here is knowing Saaty scale value and its respective meaning. Accordingly, here is a table that indicates Saaty scale value and its respective meaning. One means the two criteria are equally important in our objective. Saaty scale value 3 indicates that one criteria is moderately important than the other factor. If you assign 5, you mean that criteria A is strongly more important than criteria B. 7 indicates that criteria A is very strongly important than criteria B. When criteria A is extremely important than B, you can assign a Saaty scale value of 9. But also don't hesitate to use intermediate values. Such intermediate values are 2, 4, 6, and 8. Now, in AHP, we'll perform 3 main tasks. The first one is comparing and assigning Saaty scale value under pairwise comparison matrix for each criteria. And the second step is calculating the criteria weight under normalized pairwise comparison matrix, and finally calculating the consistency ratio of our analysis, whether it is logically acceptable or not. The first criteria is rainfall, geology, soil, slope, land use, land cover, the element density, drainage density, and the geomorphology. I have identified 8 factors or criteria that are supposed to have impact on groundwater availability. Now I'm going to compare and assign a Saaty scale value for each criteria. For example, here, compare rainfall with rainfall, rainfall with geology, rainfall with soil, with slope, with land use, land cover, and the rest of the criteria. Again, in the same way, I will compare geology with soil, slope, land use, land cover, element density, drainage density, and geomorphology. But what you have to know here is we will only fill those cells which are shaded in a yellow color, while those cells which are shaded in white colors are filled automatically. These cells, the value of this cell is the reciprocal of the value of this cell. That means for rainfall versus geology, we'll fill here and assign a Saaty scale value, and this value is equal to the reciprocal of this value. That means geology versus rainfall, rainfall versus geology are the reciprocal for each other. Let's start by comparing and assigning the Saaty scale value under pairwise comparison matrix. Here, rainfall versus geology. Rainfall is weakly important than geology. Rainfall versus soil. Rainfall is strongly important versus slope. Rainfall is important versus land use, land cover. Rainfall is important here also. Versus lineament density, rainfall is important than lineament density. In this, moderately important than lineament density. Rainfall versus drainage density, rainfall is very, very strongly important. Rainfall versus geomorphology, rainfall is strongly important than geomorphology. Geology versus rainfall is the reciprocal of rainfall versus geology. Geology versus geology is 1 or unit. Geology versus soil, geology is strongly important. Geology versus slope. Geology is again strongly important than slope. Geology versus land use land cover. Geology versus lineament density. Geology is weakly important than lineament density. Geology versus drainage density. Geology is very strongly important versus geomorphology. Geology is important. Now here, soil. Soil versus rainfall is the reciprocal of rainfall versus soil. Soil versus geology is the reciprocal of geology versus soil. And the soil versus soil is equal to 1. Now, I will assign a Saaty scale value for soil versus slope. Soil versus slope. Soil is moderately important. Soil versus land use land cover. Land use land cover is weakly important. Therefore, I will assign 1/2. Soil versus lineament density. Lineament density is strongly important. Therefore, I will assign 1/5. Soil versus drainage density. Soil is strongly important. Soil versus geomorphology. Geomorphology is weakly important. Again here, slope versus land use land cover. Land use land cover is moderately important. I'll assign or I'll give a Saaty scale value of 3 for land use land cover or 1/3 for slope. Slope versus lineament density. Lineament density is important. Slope versus drainage density. Slope is moderately important than drainage density. Slope versus geomorphology. Geomorphology is moderately important. Again, land use land cover versus lineament density. Lineament density is important. It is moderately important. Versus drainage density. Lineament density, land use land cover is important. Strongly important. Versus geomorphology. Geomorphology is moderately important. Here, lineament density versus drainage density. Lineament density is obvious that it is very strongly important. Lineament density versus geomorphology. Lineament density is moderately important. And finally, geomorphology versus drainage density versus geomorphology. Geomorphology is important. Therefore, I will assign a Saaty scale value of 5 for geomorphology or 1/5 for drainage density. Now, we have assigned a Saaty scale value for each criteria under pairwise comparison matrix. The next step is calculating the sum of each column in order to perform or in order to calculate the criteria weight under normalized pairwise comparison. We have to calculate the sum of each column. The sum of this column is equal to sum. You can use Excel formula. Sum of these all values is equal to 2.78. And again, this is also the sum of the next column. The sum of the column under geology which is equal to 4.49. You can drag and fill the cells in the same way, or you can calculate separately for each column. Now, this is all about pairwise comparison matrix. Again, we'll perform a normalized pairwise comparison matrix. Now, the second step is calculating the criteria weights for each criteria under normalized pairwise comparison matrix. In order to calculate the criteria weights for each criteria, we have to calculate the value of each cell under normalized pairwise comparison matrix. Accordingly, the value of this cell is equal to B3 divided by the sum of the rainfall column, which is 2.78. It is equivalent with 0.3597. Again, the value for this cell is equal to B4 divided by the sum of rainfall column, which is 2.78. In the same way, you can calculate the value of each cell under rainfall column. Again, under geology column, the value of this cell is equal to C3 divided by the sum of geology column, which is 4.49. In the same way, you can calculate the value of each cell under geology column, under soil column. This value is equal to D3 divided by the sum of soil column, which is 20.53. It is very simple and straightforward, therefore you can calculate easily. Again, for slope, the value for this cell is equal to E3 divided by the sum of the slope column, which is 25.33. This is equal to 0.2369. For land use land cover in the same way, the cell value is equals to F3 divided by 16.03 or F12. Under alignment density, the value of the cell is equal to the value of the cell under pairwise comparison or under alignment density column divided by the sum of the column, which is 7.28. It is very simple and straightforward. You can simply calculate the value of each cell in the same way, divided by the sum of geomorphology column, which is 50.37, which is equal to 0.3253. Now, after calculating the value of each cell under normalized pairwise comparison, we'll calculate the sum value of each rows. This cell or the sum of the first row is equal to the sum of, using the Excel formula, sum of 0.35, 0.44, 0.24, 0.323 up to the value of the first cell under geomorphology column, which is equal to 2.4725. Again, the value for or the sum of the second row is equal to the summation of those values. In the same way, you can calculate the summation of each values or the summation of each rows. Now, here our main objective is to calculate the criteria weights for rainfall, criteria weight for geology, for soil, and all other criteria. Therefore, criteria weight is equal to, here we have 8 criteria or 8 elements. Therefore, number of elements is equal to 8. Criteria weight is equal to the sum of the row divided by number of elements or 8 factors, which is equal to 0.3091. The criteria weight for geology is equal to the sum of geology row divided by number of criteria, which is equal to 0.235. Now, for the rest of criteria, you can calculate the criteria weight. Now, criteria weight in percentage is equal to criteria weight times 100%. Therefore, it is simple and straightforward. That means it is converting this value or this decimal into percentage. Therefore, this is equal to criteria of weight for rainfall times 100%, which is equal to 31%. For geology, it is equal to criteria weight for geology times 100%, which is equal to 23%. For the rest of elements, you can calculate in the same way by multiplying the criteria weight or the decimal of criteria weight by 100%. Now the summation of all criteria must be 100%. After calculating the criteria weights for each criteria under normalized pairwise comparison matrix, the final step is checking for consistency by calculating consistency ratio. Now, in order to calculate consistency ratio, we have to calculate and fill this table. The value of the first table is equal to the value of the first cell under rainfall column in pairwise comparison matrix multiplied by the criteria weight of rainfall, which is 0.3091. This is equivalent with 0.3091. For the second cell, this value is also equal to the value of B4 times criteria weight for rainfall, 0.3091, which is equal to 0.1546. In the same way, you can fill the rest of the cells. Under geology, the criteria weight for geology is equal to 0.2335. Therefore, this cell is equal to 0.2335 times the value of C3 or the value of the first cell under geology column times or multiplied by 0.2335, which is equal to 0.467. Again, for soil column, the value of the first cell is equal to the value of the first cell under soil column under pairwise comparison matrix multiplied by the criteria weight for soil, which is equal to 0.0625. This is equivalent with 0.3125. For slope in the same way, the value of the first cell is equal to E3 multiplied by the criteria weight for slope 0.039. Again, this value is equal to F4, F3 times the criteria weight of land use land cover 0.077, which is equal to 0.38. 3 times the criteria weight for lineament density 0.1628, which is equal to 0.488. This is also equal to G4 multiplied by the criteria weight of lineament density 0.1628, which is equal to 0.3256. Under drainage density column, the cell value is equal to, for the first cell, it is H3 multiplied by the criteria of weight for drainage density 0.0216, which is equivalent to 0.17. And finally, under geomorphology column, this value is equal to I3 multiplied by 0.0944, which is the criteria weight for geomorphology, which is equal to 0.47. Now, after calculating and filling all the cell values, we'll calculate the weighted sum value. The weighted sum value is calculated as the sum of each row. The value of this cell is equivalent to the summation of the first row or rainfall row, which is equivalent to 2.76. For the second, the weighted sum value is equals to the sum of the geology row, the sum of all these values under geology row. The third weighted sum value is equal to the sum of soil row. In the same way, you can calculate the weighted sum value for each row. Now, under normalized pairwise comparison matrix, we have calculated the criteria weights. The criteria weight is equal to the same as which was calculated during the normalized pairwise comparison matrix. For rainfall, it is 0.3. For geology, it is 0.23. And for geomorphology, it is 0.0944. Now, as a final step, we'll calculate the ratio of weighted sum value to criteria weight. This ratio is equivalent to weighted sum value divided by the criteria weight for rainfall, which is equals to 8.94. For the second cell, the ratio is equal to weighted sum value of geology divided by the criteria weight for geology. Similarly, you can calculate the ratio of weighted sum value to criteria weight for each and every elements. Now we have to calculate lambda max. Lambda max is equal to the average of the ratio. It is the average of the ratio of weighted sum value to criteria weight. Therefore, in a simple way, you can calculate lambda max, which is the average of the weighted sum value to criteria weight. Now, consistency index is equal to lambda max minus n over n minus 1, where lambda max is calculated from this table and n is the number of element or factor or number of criteria. For our case, the number of criteria is equals to 8. Therefore, n is equal to 8. Lambda max is equals to 8.68. Therefore, lambda max minus n is equal to, this is equal to 8.68 minus 8, which is 0.68. Now, n minus 1 is equal to, this is equal to 8 minus 1, which is equal to 7. Consistency index is equal to lambda max minus n over n minus 1. Lambda max minus n is 0.68 divided by 7. Here, consistency index is equals to this value divided by 7, which is equal to 0.0971. Here, the other criteria is random index, since consistency ratio is equal to consistency index divided by the random index. Random index is a function of element or criteria. In our case, we have here 8 criteria or 8 elements. The respective random index for 8 element is 1.4. Therefore, random index is equal to 1.4. And finally, the consistency ratio for our analysis is equal to criteria index, consistency index divided by random index, which is equal to 0.07, which means 7%. Now, in order to say our analysis is logically acceptable and consistent, there is a criteria for different matrix sizes. For a matrix size greater than 4 by 4, consistency ratio must be less than 10%. Therefore, in our case, our matrix is 8 by 8 matrix, and our consistency ratio is 7%. Our analysis, which was made during the normalized pairwise comparison, was logically acceptable and consistent. Here, the final goal is calculating the criteria weight for each factor which influences our objective. Here, what you have to know is that this is not always true for different analysis or for different assessments. Therefore, in order to judge each criteria and assign a Saaty scale value, you have to know your study area very, very well as you have to read different articles, and as much as you can communicate with different expertise. Thank you for watching. Please don't forget to like, comment, and subscribe for further improvements. See you next time with another video. Have a nice time.